In my experiment, I'm going to form a hypothesis on what will happen to the velocity of a ball as it rolls across a horizontal ramp. I think that it will slowly decrease in velocity. Let's see. My hypothesis for the inclined ramp is that the velocity will increase. I will be using markers set at 20, 40, and 60 centimeters to tell. It seems that the velocity increased on the horizontal ramp. The velocity also increased on the inclined ramp. Did the results match my predictions? Well, partially. I was right in thinking that the velocity would increase on the sloped ramp. However, I did not expect for the velocity to increase on the horizontal ramp as well. Yes, in both instances, with the horizontal ramp, the acceleration was increasing in the negative direction. With the ball on the inclined ramp, the acceleration was increasing in the positive direction. In order for the net forces acting on the ball to equal to zero, it would have to be in equilibrium, which would mean that it was either not moving or moving with a constant speed in one direction. This was never the case for either of the balls, aside from the ball on the horizontal ramp before I had applied forces to it. In Galileo's experiments, he was attempting to find the acceleration of several balls as they were going down a slope. He was doing this because, when dropping balls from free fall, it was much more difficult to measure movement in congruence to time, so finding the acceleration of different moving objects was easier to do with ramps. This was the case for us as well, and just like Galileo, we were using the balls on inclined ramps to calculate acceleration.